We will now look at improper integrals. So there are going to be a few main types of improper integrals. So these are used for two different cases. One, when the interval of the integrand is infinite, or when the integrand is unbounded on the interval of integration. So we'll start with the infinite case. If f is continuous over a to b, then the integral from a to infinity of f of x dx is the limit as b goes to infinity of the integral from a to b of f of x, provided this limit exists. So for example, let's look at this one. So this would be the limit as b approaches infinity, the integral from 2 to b of x to the negative 1/2 dx. So this is the limit as b goes to infinity of, we would add 1 to the exponent and then divide by that number. We're going to take this between 2 and b. So the limit as b goes to infinity of 2 times the square root of b minus 2 square root of 2. As b goes to infinity, the square root of b is also going to infinity, and 2 times infinity is also going to infinity. And an infinite number minus a constant is just infinity. So this integration gives us infinity. Let's now look at this one. So this would be the limit as b goes to infinity of the integral from 0 to b of sine x dx. So this is the limit as b goes to infinity of negative cosine x going between 0 and b. So the limit as b goes to infinity of negative cosine b minus negative cosine of 0. Well, this limit here doesn't even exist. So this integral does not exist. We can also have an integral running from negative infinity to b. In this case, this is equivalent to the limit as a goes to negative infinity of the integral from a to b of f of x dx, once again provided the limit exists. So we'll do this one. This will be the limit as a goes to negative infinity of a to negative 1 of x to the negative 2 dx. So the limit as a goes to negative infinity of, well, we add 1 to the exponent and then divide by that number, going between a and negative 1. So I have the limit as a goes to negative infinity of negative 1 over a minus negative 1 over, so plus 1 over negative 1. So the limit as x goes to negative infinity of 1 over a would be 0. So this is 0 minus 1. So this is just negative 1. We can also do an interval from negative infinity to infinity, and this is going to be broken up into two pieces. The limit as a goes to negative infinity of the integral from a to c f of x dx, plus the limit as b goes to infinity of the integral from c to b of f of x dx. In this c, doesn't matter. It's any real number. It doesn't matter which one you pick, you'll still get the same answer. So we'll do this one. So, This is the limit as a goes to negative infinity of the integral from a to, and we'll go ahead and break this up at 0, of 1 plus x squared dx plus the limit as b goes to infinity of the integral from 0 to b of 1 plus x squared dx. And the integral of 1 over 1 plus x squared is inverse tangent. So we now have the limit as a goes to a negative infinity of inverse tangent between a and 0 plus the limit as b goes to infinity of inverse tangent from 0 to b. So now we'll evaluate this. Tangent inverse of 0 minus tangent inverse of a plus tangent inverse of b minus tangent inverse of 0. And you can see that this tangent inverse of 0 has a plus and a minus and it cancels. And this is why it doesn't matter where we break this integral, because it's going to cancel either way. As a goes to negative infinity, the inverse tangent goes to negative pi over 2. And as b goes to infinity, inverse tangent is going to go to pi over 2. So we have pi over 2 plus pi over 2, which is pi.